Welcome to Stocksoft Center training program on design of steel structures and its connection using STAAD.PRO, Idea Statica and Excel. So this is our first session. Today we are going to start our discussion on design of steel structures. We are going to discuss regarding steel. Steel as a structural member. Most of you over here have done their civil engineering, have done their structural engineering. We always study structural engineering keeping in mind of you of RCC construction like a building, house, commercial structures. Generally RCC is kept in mind because in India 90% of our projects are focused on RCC concrete structures. But similarly we also have studied steel where we have industrial warehouses, industrial structures, commercial structures, where steel is used as a primary material, a predominant material. So let us understand why we use steel as a structural member. What are its properties which make it possible to use steel as a structural member? Let us see some of the mechanical general properties of steel. First and most important property of steel, steel is having a particular strength to it. When you apply certain kind of load over steel, it will not easily bend, it will not easily buckle. So steel has particular strength. Because of this strength, we can use steel as a structural member to carry all our load coming on it. Steel is ductile in nature. What is ductility? It means that you can bend steel in any form you want. You can convert steel into any kind of shape you want. That is one of the advantage of steel. It has certain ductility. It is durable. What is durability? It is strong. When certain kind of load is applied over it, it will not easily break, it will not easily bend. It is a durable material. Recyclability. Steel is a kind of material which you can use during its lifespan, and after its lifespan is completed, you can just melt it and again convert it into another form of steel. So steel is a recyclable material. This is one more advantage of steel. Then fire resistant. In general, steel is not a fire resistant material, but when you apply certain coating over it, it becomes fire resistant. That means when certain coating is applied over it, it can withstand fire at a great level. So this is another advantage of steel. And finally, uniformity. As compared to RCC, where in RCC you have your concrete, aggregates, cement, sand, and the mixture of these things form into concrete. And there is high possibility that there might be non-uniformity in the concrete what you have just made. But in case of steel, steel is a uniform material. It has uniform cross-sectional properties throughout its cross-section. Because this is produced in a molten form in some factory, and it will have uniformity throughout its thickness as compared to RCC, where you can have maybe little more strength at certain place and little less strength at some other place. But in steel, you will have a uniform property. So these are some of the properties of steel. All of you might be aware of them. We are just having a quick overview of steel, why it is being used as a structural member. So yeah, let's go to the next topic. The mechanical properties of steel. Now, what are some of the mechanical properties of steel which make it suitable to be used as a structural member? These are the properties which are useful for us during our design, during our calculation. So, number one, modulus of elasticity. Now, I want everyone to answer in the comment section. You can just let me know what is the value of modulus of elasticity of steel. What is the Young's modulus of steel? If anyone wants to answer, you can tell me what is the value of modulus of elasticity of steel. Okay, no one is answering. So let me tell. The modulus of elasticity of steel is 200 GPa. Now let me explain you quickly what is this. The modulus of elasticity generally denoted as E. It is also called as Young's modulus. It is the ratio of stress versus strain. Stress versus strain. This is called your modulus of elasticity. Now what is stress? Stress is the force applied on your member divided by its cross-sectional area. Force by area. The internal pressure which is developed in your structure because of the load applied on it, that is called as stress. It can be also denoted as force upon area. And what is strain? Strain is change in length of your member because of the applied force. Original length by the final length. So you can just say change in length, or original length by final length. L by L dash. This is the ratio of your original length by your final length. Change in length by your final length, total length. Okay, let's denote it in a better way. Delta L. This is your change in length divided by your original length. So this value, in case of steel, it is 200 GPa. Now what is GPa? GPa stands for gigapascal. We can also write this as 2 into 10 to the power 5 megapascal. Or you can also just write as 2 into 10 to the power 11 Pascal. Yes, this can also be written as, maybe let's write 2 into 10 to the power 2 gigapascal, which can also be written as 200 GPa. Okay, gigapascal, megapascal, and pascal. So this is the value of modulus of elasticity of steel, stress versus strain. I hope this is clear to all of you. Next important value is modulus of rigidity. The modulus of rigidity of steel is 77 GPa. This is not very important for us from structural point of view, but yes, this is also another value. Let me change the color. This can be denoted as G. G stands for modulus of rigidity, and again the value is shear stress divided by strain, shear strain. If you want to see the example of this, you can consider this as one of the box or cube, and when certain shear force is applied over it, this box will tend to move in this direction. There will be certain change in angle because of the force applied, and force may be applied on the area A. So here again the formula becomes force by area, which is the stress, divided by change in theta to the original theta. Here it is change in length. If you want to see the Young's modulus, it can be also written as, if this is your member and certain force is applied on it. Here you can see force by area divided by change in length by original length. Okay, maybe this can become like this, and this value will become delta L, change in length. Okay, so modulus of rigidity is less, it is slightly less compared to modulus of elasticity, it is 77 GPa. Third important parameter is coefficient of thermal expansion. The value of coefficient of thermal expansion is 12. Now what is the value? Okay, red is fine. 12 into 10 to the power minus 6 per degree Celsius. It means that if you this value is in per degree Celsius. So for 1 degree change in temperature, 1 degree Celsius change in temperature. If you have any object, if you have a steel bar and the temperature is increased by 1 degree Celsius, then that member will increase in length by 12 into the 10 to the power minus 6 meter. So it is, if you write in millimeter, 0.012 mm. This will be the increase in length because of 1 degree change. So in this way you can try to understand what is this coefficient of thermal expansion. And finally you have the Poisson's ratio. Poisson's ratio is again the value of strain. Poisson's ratio, let's again change the color. It is the value, let's assume this is your object and you apply force over it. Because of this applied force, your object will become slightly thinner like this. It will become longer, right? So original depth was D, capital D. Now that depth became smaller and became small d. Original length was capital L. Now that length became slightly larger, and this change in length may be delta L. So this became L plus delta L. So the length slightly became longer and the width, the depth slightly became smaller. So lateral strain by longitudinal strain. This is your Poisson's ratio. This value of lateral strain by longitudinal strain is between 0.3 to 0.5. Okay, so these are some of the general mechanical properties of steel. I have also explained you the meaning of each term. Let's see some of the grades of steel which we can use as our structural member as per our IS code. We have this IS code IS 2062 in which you have certain grade of steel which you can use. Most of the time for your steel structures, the grade of steel what you will be using is E250. It can be either A, BR, B0C. These are some of the qualities of steel. But for you, what is important is the tensile strength, that is 410 MPa, and yield stress. It depends on thickness of your member. Generally, the thickness of our member is less than 20, so the value is 250. So for E250, which is the grade of steel which we will be using 90% of the times, in this you have your Fu value, the ultimate strength of your member, that will be 410 MPa, and then you have the value of Fy, the yield strength of your member, that will be 250 MPa. So this is the grade of steel what we will be generally using. You might have also studied E410 for your reinforced bar which you use in concrete, reinforced steel, that generally has the property of E410, or nowadays you also have E500, E550. So for them the value is either I'll change the color for them because this is not our general practice in general structural steel, but these are used for reinforcement bars, 410, or it can be 550. So these are some of the properties of steel mechanic. Okay, so in our case we will be using E250. Fu is 410, Fy is 250. Nowadays some companies, like you have Tata Steel or you have JSW Steel. So these companies, they also try to make steel in some other grades. We have grades like 235, 235. We also have grades like 355. Yeah, so these are also some of the general grades of steel which are available in the market, which are produced by certain companies like Tata Steel, JSW Steel, Jindal. So these are equivalent of the grades which are available in other markets like European and American markets. In India, generally, as per the Indian standard, this is the common grade of steel what we will be using. But nowadays, also these kind of materials are being used. 235, 355, maybe also 420. So these are some of the grades of steel also which are being made available in the market nowadays. Okay, so let's now see the most important thing before we start understanding steel. This is the graph what you all of you have studied in your college days. This is your stress versus strain graph. This line represents your Young's modulus. Here you have your yield strength. For example, let's assume this graph is for each grade of steel will have a different value of graph. If you have E250, if this graph is particularly made for E250, then initially when stress applied on your member is zero, of course the strain will be zero. But as you increase the force which is applied on your member, let us assume this is one bar, and on this bar you are applying certain force. Because of this force, you are applying certain stress, maybe force by area. What is stress? Stress is force applied divided by cross sectional area. So you are applying certain force on your bar. Because of this applied force, this bar is changing its length. Slightly it is becoming longer. And when you release this force, again it is gaining its original shape. So when you apply certain force, it becomes longer. When you remove that force, again it becomes back to its original shape. So this is called elastic limit. So from this level up to this level, your member will be under elastic limit. It means that when you apply certain force on your member, the member will bend, the member will change its length. There will be certain strain in the member. So this will be that certain strain value. And the Young's modulus, the yield strength limit of your E250, the stress will be 250 over here. When you apply a stress of 250 and you remove that force, again your member will come back to its original shape. But if you again go on increasing the force, maybe you go up to this point. Let's assume this point to be around 300. Now when you remove back the force, there will be certain permanent change in your member. This was the original member. You applied this force, it became like this. But now when you removed the force, it will not gain the original shape again. It will become like this. So this becomes strain hardening region. Slightly it is moving towards the plastic region. Okay. And there will come a point which will be the ultimate strength of your member. Beyond this, your member will not be able to take the force. So this point is called the ultimate strength. And right now we have seen the ultimate strength of E250 is 410. So beyond 410, if this is the member, you go on increasing the force. After 410, this will just break. This will just break. This is your ultimate strength of your member. But we have also studied that maybe this is your member. You have applied force of 410 and then you removed your force. But still Because of the applied force, there was this kind of necking which was generated. And even though you are removing the force, even for a smaller force, because of this necking which is generated, the member is finally breaking. The member is finally breaking. This is called the necking area. Okay, so yes, this is related to stress versus strain curve. I hope this is also clear to all of you. 300 is proof stress, Akash. It's not like I don't understand what do you mean by proof stress, but until the yield strength, whatever force you apply, until the stress of 250, whatever strain will be there, that will come back to its original shape. That means there will be zero strain. But after 250, this 300 is just an example. This value can be 350, 330, 340, anywhere between 250 and 410. When you apply stress and when you remove it, then there will be certain permanent deformation in your member. That is what I was trying to tell. So you cannot just say that this value what I am writing, this is maybe like a permanent proof stress or something. This can be any value between 410 and 250. So let's not write any value over here. But 410 is the maximum capacity of your member. Beyond 410, your member will just break. That is your ultimate strength. Okay, so this is stress versus strain graph. I hope this is clear to all of you. This was some of the general properties of steel, general concepts of steel, where we understood why steel is used as a structural member, what are the properties of steel, Young's modulus, modulus of rigidity, okay, coefficient of thermal expansion, grades of steel. That was very basic. Now the important part, some of the basics of structural analysis. Now in general, let us understand what is structural analysis. When certain kind of force is applied on any member, then what happens, how you can analyze the forces which is coming on it. Let's understand forces, what is equilibrium, what are the support conditions, what is free body diagram, what are the various loads which we can apply. So this is what we would be discussing now. Very basic, very common. The two kind of things what can be applied on your structure is forces and moment. Force will of course have certain direction. Here you can see it is downward in direction. It will have certain magnitude. It will have some value, and there will be some point of application where this force is applied. Moment, again you will have certain magnitude. There will be some value of moment. It will have certain direction, and it will have axis of rotation. So if I try to explain you, if this is your member and you are applying some force over it at this particular point. So this is normal force which is applied. But in this member, if you are applying one force like this, another force like this, two forces in opposite direction separated by certain distance x, they will generate this kind of moment. These two forces will generate this kind of moment. So this is, you will have axis of your rotation, you will have certain value. So this is the general comparison between force. So moment will be F into x, the value. Force into perpendicular distance between them. So this will also be, of course, F. Same force is applied. What is equilibrium? When you are studying your two-dimensional analysis, if this is your object in two-dimensional analysis. Thus, if your member is static, if you are having some member, let's assume you are having this ball, and if this ball is not moving, it is static in condition. So in this ball, whatever forces you are applying, instead of ball, let's take example of a cube, and maybe this cube is kept on ground and it is maybe supported or welded on ground, and you are applying certain force on it. Because of this certain force, there will be some reaction, and overall summation of force will be zero. Because of this force, you will have some reaction over here. Fx, this force you can convert into Fx, this can be also converted into Fy. This reaction also can be converted into Ry and Rx. So you can see summation of force in x, Fx will be equal to Rx. So this both are in opposite direction, summation is 0. Fy, summation of Fy will again be equal to 0, and the summation of moment which is being applied on this, again that will be 0. So these are the three equilibrium equations which will be applicable in your 2D structure, two-dimensional structure. But same thing, if you go for a three-dimensional structure like this, you will have forces in x, y, and z direction. All of them will be 0. Summation of forces in x, y, z direction, and summation of moment in x, y, z direction, they will be 0. So here you will have 6 equilibrium equations, and in two-dimensional you will have 3 equilibrium equations. So this is important. Type of forces what we will be having. There will be certain external forces, the forces which we are applying on the member, and because of those external forces, there will be certain internal forces which are the reactions. Or you can have forces depending on the type of force. Either it could be a dead load, live load, wind load, seismic load, temperature effect. So these are some forces. So here you can see F1, F2. These are forces which are applied externally on your beam, and because of them, there is certain reaction which is developed from these supports, RL and RR. These reactions are called as internal force reactions. Okay, so these are some type of forces. Support conditions, you can have either a roller support. This is the representation of a roller support where you will have only vertical reaction. Horizontally, this support will move, so no reaction will be developed. Then you have pin support where you have horizontal and vertical reactions. You have fixed support where also you have horizontal, vertical, and moment. And you have simple support like this. Let me show you in a better way. Free body diagram, this will be easier. If you have this kind of pin support, the reactions which we will be developing is Ry and Rx. If you have a beam which is placed on some plate table like this, again you will have Ry and Rx, and there will be some frictional force because of the friction between these two surfaces. And if they are rigidly connected, then you will have this kind of Ry and Rx. So this is the type of pin connections what we have. For roller, you have this example. Because you have rolling over here, whenever you try to apply the force Fx, this object will directly move. So there will be no reaction which will be generated. Only Ry will be there. And if your body is not having any friction, again only Ry will be there. And this is another way of representation, force Ry. Then we have this fixed support, where also your rotation of the member is not allowed. and then because of that rotation there is this moment which is developed, which is mr. So these all are two dimensional drawings what we have. That is why you can see you are having three reactions: rx, ry, and a moment. In case of a truss, you will have this kind of. If for a simply support connection, you will have rx, ax, and ay. For a pin connection where a roller is allowed, you will only have by. Again, similarly, for whatever forces you are applying, for your fixed support, you will only have x, y, and moment. Now let us see some of the loadings what we can apply on our member. You have point load, where a point load is applied at a particular location. Then you have uniformly distributed load, where your load is applied throughout the length of the member in the form of a UDL. Then you have trapezoidal load distribution. At one end, the force is slightly more, and at the other end, the force is less, and there is trapezoidal distribution of load. And you can also have moment. Moment is developed at a particular point, and it is represented like this. Okay, so these are the all kind of different loads what we have seen, but all these load on a particular structure, maybe they are acting simultaneously all together. You have dead load, live load, wind load, seismic load, snow load, thermal load. These are some of the loads what can be acting on your structure. And because of these loads applied, you have combination in two types: factored load combination and service load combination. So if you want to check the strength of your member, you go for factored load combination. And if you want to check the serviceability of your member, like deflection, you go for service load combination. We will be discussing this again in detail later on. So this is the table from our IS code, IS 800, which tells you what are the factors what you should be using for these loads applied. So we will be again discussing this table in detail later on. This is just a quick overview. Okay, so this was a quick summary of the structural analysis. Very simple. I just showed you some of the forces, some of the support conditions, some of the loading types, what are equilibrium equations, very basic things before we start with our structural analysis and steel design. Everyone kindly tell me in the comment section if all things are clear to you. Should we move towards structural framing? Quickly answer in the comment section and tell me if everything is clear to all of you. Okay, so now we are moving towards important topic. Yes, structural framing. Generally, yeah, let me show you. Let's assume this is your column, beam, column, and let's assume it is fixed on the ground, maybe fixed support. This is member 1, column, member 2, beam, member 3, again your column. Various kind of loadings what can be applied on this. You have your gravity loads which are applied in the direction of gravity. Gravity loads, this can be either dead load of your structure, live load, or whatever collateral load, the loading which are applied in the direction of gravity, the gravity loads. And second kind of loads what you will be having, lateral forces. This can be wind force which will be acting on your structure. It can be seismic forces. So these are the example of lateral forces. So generally in gravity forces, I give the example of dead load, live load. And in lateral forces, I give the example of wind load and earthquake load. Okay, so these kind of forces, these two type of forces can act on your structure. Now if you see, member 1 and member 3 are your one dimensional vertical members. These are one dimensional members, only one dimension, and you can say member 2 is your one dimensional horizontal member. Very simple. Same thing if you go for three-dimensional thing. I'm drawing again a three-dimensional thing. I have drawn a 3D frame. In this, you can see we have four vertical members. One, two, three, four. And again, four horizontal members. Five, six, seven, eight. And you have one two-dimensional member, which is nine, the slab area. So in this figure, we can say from 1 to 4, you have same 1D vertical member, and 5 to 8 you have 1D horizontal member, and ninth one is your two-dimensional horizontal member. Is this clear to all of you? Yeah, some basic things. Now if you see in your one-dimensional horizontal member, what all things you can have. If you are having your one-dimensional horizontal member, what all things you can have? It can be a beam, it can be a normal beam, I section, or maybe channel section, or whatever it is. Second option, you can have a truss. You can have this kind of truss. Or you can have an arch. These all are example of one-dimensional horizontal members, right? One-dimensional vertical members. In this, you can have generally a normal column. a vertical column. This can be an example of an one-dimensional vertical member. Yes, in beams, let me also show you one significance, one comparison. If you are having this RCC beam, a small comparison between steel and RCC. This is your RCC beam, and maybe certain load is applied on top of this. A UDL, maybe a UDL is applied on top of this beam. Because of this applied force, what will happen? The top area, it will try to bend like this, right? Top area will be under compression, bottom area will be under tension. Yes, this all of you understand. And these area in between, they may be under shear. This many of you don't, maybe are not understanding, but this is general. The top area, because you can see it will be under compression, the bottom area will be under tension, and the middle area will be of course under shear. This is an RCC concrete beam. Similarly, what is steel beam? In beam, what we have done, we have just converted them into separate members like this. Your top chord is under tension, under compression because of the load applied. Your bottom chord is under tension, and maybe your diagonal members are under shear. So this RCC beam and the steel beam, steel truss, they both are carrying the same force, and the structural mechanism is also same. The top area under compression, the bottom area under tension, and some of the central part under shear. But we have just replaced the concrete with steel. Why I am telling you this? For a column, when force is applied, let's assume this is an RCC column, and second place you have your steel column. On both the members, force is applied. You have steel is good in tension. Whatever tension force you apply on steel, steel is a better member to carry tension force compared to concrete. Concrete is bad in tension. Concrete will not be able to carry the tension force, but steel will be easily able to carry tension force. This is one of the difference of steel and concrete. Similarly, if you have steel under compression, concrete under compression, and steel under compression, Steel will maybe buckle like this, but concrete can carry the bearing. Another statement you have, steel is bad in compression and concrete is good in compression. How many of you agree with these statements? Every one of you are aware, every one of you agree with this statement. Steel will carry tension force easily, but concrete will not be able to carry tension force. Steel will not carry compression force, it will buckle, but your concrete will easily carry compression force. That is the reason for reinforced concrete. Now we have this term, reinforced concrete. If this is your concrete beam, what we do, in the bottom you have your reinforcement. Here, because you have tension, and at top you have compression. Compression can be easily taken by steel, and because compression can be easily taken by concrete, and because the bottom part is under tension, and you know concrete is weak in tension, that is why we have this additional reinforcement bars at the bottom, which will help concrete in carrying the tension force. So that is the reason this is the term reinforced concrete, the mixture of steel and concrete, reinforced concrete. Now I also explained you why in concrete you have this reinforcement, because your concrete is weak in tension and this reinforcement can help concrete carry the tension force. Yes, the horizontal members. Now let us see from steel point of view to the horizontal members. In RCC, what you can be having, you can directly have certain thickness of slab as your two-dimensional member. In RCC, you can directly have slab maybe of thickness 150 or 200 whatever is the thickness of your slab. You can directly have this kind of slab. But in steel, you do not have this kind of thing. You do not have steel slab. First option we have in steel is the primary secondary beam grid. What does this mean? If you see the plan view, this will be your first beam, this will be your second beam, and these will be your primary beams, and on top of this you will have your secondary beams like this, and on top of these secondary beams you will have your checker plate. If you see the cross sectional view, this is your primary beam, this is your second primary beam. These primary beams maybe are connected by a number of secondary beams in this way. They may be bolted here, they may be bolted like this, and on top of this you will have a small 6 mm checker plate. So in this way you make something similar to your concrete slab, a combination of primary and secondary beam grid. Second option you have is the rafter purlin system. Now what is this? Let me explain you. You are having this warehouse. Okay, I'll draw just one member like this, another member like this, again one member like this, another member like this. These are your rafters. Let's draw one more. These are your rafters, and on top of these rafters you can have these purlins, similar to primary secondary grade, but they are termed as rafter purlins. And the arrangement is slightly different. If you see, you may be having this kind of rafter. This is the flange, web, flange, and on top of them you will be having your purlins like this. Rafter purlins. Third option, you can also have truss purlins. In this, what you will be having? You will have this kind of truss. This is one of your truss. Again, you will have another truss. And these truss are connected by your purlins. You have seen these kind of structures, industrial warehouses and all. Next thing nowadays, which is more and more becoming common, a complex thing, space frame. Now this will become slightly difficult to draw. Let me show you some picture. What are space frames? You might have seen these kind of structures. These kind of structures, they are called as space frames. Yes, let me copy this. I can show you over here. This is the example of space frame. Okay, so these are some of the two-dimensional elements. Like you have space frame. Generally, we have truss purlin, or you can have rafter purlin. Okay, sorry, this is fourth one. Or you can have your primary secondary beam grid. So these are few examples. Tell me, is the framing part clear to all of you? Is the framing part clear to all of you? You can answer. Okay, now we have understood steel as a
I have
structural
one
member.
small
We have
question, sir.
understood.
Hello.
Yes,
Can I have one question? One, excuse
yes,
me.
yes.
Yeah, this is you have given shown the truss frame. That is also comes under space frame only, no? Right?
No, let me show you. Let me explain you. This is a different kind of space frame. You can see you have truss in both the directions. Here also you have truss. In other direction also you have truss. And in between also you have truss in two directions. And on top of them you have some purlin mixture. But if you see over here, normal truss purlin, in one direction you have all your trusses. And in the other direction you have, if I show
You
you
have a
this
rafter, right? Other direction also, but rafter is also a frame.
rafter is not a frame, rafter is a beam. Okay, let me show you. If this is your x and z axis and this is your y axis, this thing in your x direction, along your x direction you will have all your frame, all your truss, like this. In the x direction you will have all your truss, and to connect all these individual trusses in y direction you will have your purlins. So
Yeah,
this
sometimes
is
in some areas we'll connect with the frame also.
with
That time it
rafters.
will be, yeah, between the rafters we connect with the one more frame. Uh, that is only for see, without only purlins we can do, but sometimes we also
Hmm.
requirement based on the requirement we run a truss also. One
Again
more
you
truss.
have a truss in the other direction, then it
Other
becomes
it's
space
space
frame.
frame. Yeah, yeah. That's what my question is. Yeah.
Here you can see, yes, this is one direction of truss. Again in the other direction, again you have one more truss. You can see. So in XY
Loading
plane, you have
one
multiple
way loading it
trusses.
is two way loading.
So,
That's what you
so,
said.
so this is a different. It comes under space frame.
It is only one way
But in
loading.
general, what we have, hmm,
If there is
in
another
general, in
direction
most of the
loading also is
industrial
there, then
warehouses,
we
what
can.
we have is, I will explain you the advantage of this kind of framing also, and the advantage of this kind of framing also. Okay, when we move towards our next classes we will understand the advantage and disadvantage of these two type of frames, space frame and normal truss purlin. In
Yeah,
truss purlin you can see
when we
in my
loading in two directions, I think we'll call it as a space also will come. Another direction loading also will come.
yes,
Only in
yes,
one direction
yes,
loading, then
yes.
it will be a single frame.
Yeah, not exactly like that, but maybe quickly I can explain you. If you are having this kind of structure, this is your, maybe we'll take a rafter, these are your rafters, these are your columns, these are your column rafters, and on top of them you have your purlins. So now what happens when force is applied this direction in this direction, it is okay because your rafter, your frame rafter, the red color frame is able to, the red color portal frame is able to carry the forces because of the yellow forces. And but the problem is when you have major forces in the other direction, this direction. If you have forces in the other direction, your portal frame will not become active, and most of your load will be transferred to your purlins. And maybe if you have bracings over here you also have bracings, then the purple color force will be taken by your purlins and bracings. But if this purple color force is also very heavy, and if these purlins and bracing are not able to carry this force, then you need portal frame also in the other direction. Then the concept of space frame comes into picture. When you have lateral forces, very heavy lateral forces in the both directions, in that case you will go for space frame. But most of the cases we have portal frame on one side and the purlin bracing framing on the other side. So yeah, you said it right. When you have lateral forces in both directions which are dominating, then you can go for this frame. Truss purlins, you have rafter purlins. This is different, primary secondary grids. Okay, I hope slightly it is clear. We understood basic framing. Okay, one more thing I want to explain. Vikas and George, many of you are asking PEB framings. Let's also add in this PEB framing. I think fifth one. What happens? This rafter, I explained you have these rafters, and then these rafters are connected by your purlins. Now in rafters you can have two, three types. Either it can be a standard member. So a rafter, what is a rafter? This red color member. It can be a standard member like this. This is the flange. This is the web area. Again the flange. Okay, let me try to draw properly. Okay, and another option you have is the PEBs. Now, what is PEBs? Maybe slightly with a rough diagram, I will explain you. The concept in detail we will be understanding later. This is your top flange. Now, the interesting part in the bottom flange is you can have tapered sections like this. You can see the thickness over here is less, and at the center the thickness of the web is becoming more. So in general, if you see the cut piece, it will be like this, and your standard member will be, in first case your standard member was normal rectangular profile, but in the second case your profile becomes tapered section like this. So these are the example of pre-engineered buildings where, as per the requirement, you change the depth of your web. So again, the theoretical part, the more structural part, we will be understanding later as and when required. But right now, you can just understand when you have tapered sections that will be part of PEB framing. PEB is tapered sections. Okay, so is this clear to all of you? Difference between normal conventional sections and tapered sections. George, Vikas, Ramarjun, you can answer if this is clear to you. Then let's move towards the next part. Introduction to STAAD.PRO. Now what we understood are some of the basics of structural framing, steel as a structural member, structural analysis. One thing I want to explain you before moving towards this thing, STAAD.PRO. vertically upward y-axis, horizontally x-axis, and horizontally in the other direction z-axis. This is the dimension. This is the axis which is there in your STAAD.PRO, the global axis, the axis what we would be following. And let us assume this is one of your beam. Which is pin connected on both the sides. So you have, for a three-dimensional member, you have 6 degrees of freedom. What are the 6 degrees of freedom? Movement in x direction, movement in y direction, movement in z direction. Then you have moment in x direction, moment in y direction, moment in z direction. For this kind of pin support, what do you have? Force in x direction, this becomes 0, or we can say this is restrained. That means for this pin support fx, fy, fz, that will be restrained. You will have certain forces which will be developed, but the moment is released. Mx, my, mz. Mx, my, mz will be 0 in this case, but fx, fy, fz, that will be there, and there will be certain forces which will be developed in these pins because of this kind of pin connection. Yeah, a normal thing. Now let us see what is STAAD.PRO. Basically, most of you are aware of STAAD.PRO. STAAD.PRO is the software. STAAD.PRO stands for Structural Analysis and Design Program. Structural Analysis and Design Program. It is a software created by company Bentley Systems. It is most widely used structural software in the industry. It is capable of designing any structure in more than 90 international codes, including steel, concrete, timber, aluminium design codes. It is used to design various kind of complex structures which you can analyze your structure for static, dynamic, wind, earthquake, thermal, as well as moving forces. And it is used to design bridges, culverts, buildings, stadiums, and many complex structures. You have various kind of versions. You have STAAD.PRO Connect Edition version 2022, STAAD.PRO Connect Edition, STAAD.PRO V8i version. This was the very famous version which was used few years ago. But nowadays in the industry, you have this latest version, STAAD.PRO Connect Edition, which is used everywhere. And we are going to deal with the latest version of STAAD.PRO. Okay, so before moving to this part, let us quickly open STAAD.PRO and see the interface. From tomorrow onwards, we can start modeling in STAAD.PRO, but today let me just show you how STAAD.PRO looks. Everyone can answer in the comment section and tell me if everything is clear to all of you. Okay, so when you open STAAD.PRO, this is the window which will appear to you. STAAD.PRO Advanced Connect Edition. This is the interface. Here you have option to open any existing file. All your existing files will appear over here. You can create a new file by clicking on new. Let's click on new. If you click on new, this is the window which will appear to you where you can give your file name. You can choose the location where you want to save your file. Let's choose some location. Okay, you can use the type analytical. All our type will be analytical type. Units can be English or metric. In English, you will have your dimensions in feet, inches, and your loading in pounds. In your for metrics, you will have your meter, centimeter, and your loading will be in kilonewton. So we will always choose meter, kilonewton, metric system. And once you add all this information, you can click on create. If you click on create, this is the interface which will be visible to all of you. Here you can do all your modeling and step by step all the process we can follow over here. Here you can see these are various ribbons, various buttons, what you will be using. Here you have some workflows. In the right side, you have few beams where some information you can enter, and this is your main white screen, your working area. At the top, you can see over here analytical modeling. Step by step, you have to work. First, you need to create your geometry. After creating your geometry, you can assign the properties to your members, what you have created. Once you assign the properties, you can assign the material to your members. Then you can assign certain specifications to your members. Then assign your support, apply loading over your member, give the analysis command, and give the design commands. So these are the processes what we can follow: geometry, properties, material, specification, support, loading, analysis, design. So this is the same thing what I tried to explain over here. First, you have to start with your geometry. Once you prepare your geometry, you can assign the properties. After assigning the properties, assign the material, their specifications, support, loading, analysis, design, and then you can visualize your results. So step by step, each and every point we will be discussing in great detail, and at the end we will be able to understand all the workflow properly. Let us see what are various tabs.
Sir, this STAAD.PRO 22 version, this one what you are using is 22 version,
Yes,
but this is I have 8 version 8, so a lot of differences.
V8i,
STAAD.PRO
StatPro
version
V8i. You have older
V8,
version
yeah,
StatPro V8i.
yeah, that is
That is the
okay,
older version. That is okay, but I would recommend that you can download the latest version.
but
The
this
issue
we
with
are
the
not
stat,
getting. Yeah, we are not able to get in the market. This
yes,
one.
the you can connect with the management. You can connect with the stock center team. They will help
Oh,
you.
okay, okay,
Okay, so you can connect with them. They will help you regarding software installation and all the process.
okay. Thank
The
you.
StatPro V8i was the older version,
Yeah,
maybe five
older
six
one.
years
Here
ago. Yes,
we have so many options. I'm not able to get there.
yeah, there is
Okay.
lot of difference in the interface.
Yes, yes, yeah.
Only the basic front interface is changed in StatPro V8i version and StatPro Connect Edition. So Connect Edition has become more user friendly and more better. The basic concept is same. Still, you can use V8i version, but it is always better to work with the latest updated version available in the market. Okay, so here at the top you have File tab. From here you can manage all your file settings. I will be showing you. Then you have this ribbon. This area is called ribbon, where you have all your buttons, all your commands, what you will be using in your daily modeling purpose. Here you have your workflow. Various kind of options will be there. At the bottom you have the status bar. This is your view window or working window. Here you have data area. Here you have data of your members, nodes, model status, workflow page, working area. Okay, at the top you have connect tools, some of the help sections available over here. Tool search, you can search certain tools over here if you are not able to quickly find here. And quick access bar, some options which you use in your daily life, you can save it under quick access toolbar. So some of the basics. The first page I showed you, from here you can open your existing files. In the new tab you can create a new file. In the license and configuration you can check your existing licenses and configurations. Announcement, here you have latest announcement by Bentley related to the STAAD.PRO. Here you can give your project details. Then here you can see the license availability option. At the bottom you have some social media following options of STAAD.PRO Bentley systems. Okay, so these were some of the things. Let us quickly have a look. Simple modeling. Now I will be quickly showing you. This is your first page. File I have showed you. Here you have all these options.
Hello.
Yes. Yes. So in the geometry, when you click, when you start your file, you can start. This is the page what will be visible to you. We will always start with the geometry. At the right hand side, you can see this structure one, whatever is the name of your model, nodes. Here you can enter your nodes. Node number one is blank right now, X, Y, Z. Let us start with the value 0, 0, 0. This is your coordinate system. So point number 0, 0, 0. Here you can see one dot is created. Next dot, next dot we can go towards the X direction. Maybe let's say 2 meters. Again 0, 0. You can see another dot is created. Now I want to connect these two nodes. So for that, if I go in the ribbon, you can see here I have the option add beam. Let's click on this option add beam and click your first node to the second node and then press escape button. So this is your first beam what you have modeled. In the right hand side, you can see at the bottom you have beam number 1. Node A is 1, node number 1, node B is node number 2. So in this way you have some information. Here you have the information of nodes. Here you have information of the beams. Here you have modeled the beam in geometry. Very simple thing what we have done. Now I want to assign certain properties to it. Then I will go in the properties tab. In properties tab, here I have the option of properties and there are many options. Today I will only explain you related to section database. If you click on this section database, it will take some time, but a window will pop up. Section profile table. Section profile table. So here you can see, if I click on this American again, you have list of various kind of countries: American steel joist, Australian, Brazilian, British, Canadian, Chinese, Dutch, European, French, German, Indian. So all the countries are available over here with the standard profiles which are available in each and every country are separately listed over here. We are interested in Indian, so you can click on Indian. Again in Indian you have various categories. Right now let's only focus on S shape. In the S shape you can see various kind of members. You can see beams, ISLB 75, ISLB 100. So these are some of the standard beams which are available in the market. I will go for ISMB 100. Okay, and I will just click on add and close it. So here you can see ISMB 100 is written, but I have not assigned this to my beam yet. So assignment method, you have four assignment methods. Right now I'm using this use cursor to assign. By default, this is chosen. ISMB 100 is also selected. I will just click on assign, go to my member and click over it. Now you can see R1 is written over here. I can press escape. R1 stands for reference 1. Reference 1 stands for ISMB 100. So this property has been assigned. Material, because I have chosen ISMB 100, by default the material is steel. Specification, right now I am not assigning any specification. I will be explaining you this later on. Next you have support. In support you have the option over here, create a new support. Click on create. Once you click on create, this window will pop up where you have fixed, pinned, fixed but, and various options. Right now let's go for pinned. If you click on pinned, you can see restrained. I explained you restrained fx, fy, fz. These three are restrained, and mx, my, mz are free, released. So just click on add, click on support to, use cursor to assign 1, 2, press escape. So you can see 2 pin support has been assigned. Loading. In loading you have these three options: definition, load case detail, load envelope. Focus on load case details. Click on add. First you need to give load case 1. You need to give any name. Let's give the same name, default name, load case 1. Click on add, then close it. Now you can see load case 1 has been added. Click on it and click on add. Now here you have various options. Let's click on member load and let's apply the value of -2. Why applying -2? Because generally global y direction is upward and I want to apply load in the downward direction. So I'll write the value of minus. It will be -5, some value, kilonewton per meter. Click on add, close. So -5 kilonewton per meter GY has been added, but you can see a question mark over here. This tells us that this load is added over here, but it is not assigned to my member. So to assign it, again, use cursor to assign, click on your member. You can see UDL has been applied. Press escape. You can see the question mark is also gone now. Next step is analysis. Go in define command. Print option, no print is fine. Add, close. That's it. Design we will do later on. After you do this thing, in the analysis and design tab, you have the option run analysis. Click over it and click save. The analysis is done. You are getting 0 errors, but one warning is there. Okay, and you can just click on done. If you want to see the results, in the workflow, you have the option of post processing. Go in post processing, click OK. If you press Control button and move your wheel of your mouse, then you can see the deflected shape. So you can see this is the deflected shape. If you click on MZ, over here you have the option. If you click on MZ, here you can see the bending moment. And displacement, if you click again, the green line is gone. If you press Control button, you can adjust the value. FY stands for shear force. Let us check. Close MZ. This is your shear force. Shear force, bending moment, deflection, all the things we have seen. Okay, so these are some of the basic modeling what we did. If you want to go back into modeling, go in analytical modeling. In the top you have option of view. If you click over view, and if you here you have various cubes. In this you have one of the cube which is front view. If you click on front view, the front view will be available to you. Okay, so today we have done a small modeling in STAAD.PRO of a simple beam. We understood why we use steel as a structural member. What are some of the structural analysis basics? From tomorrow onwards, we will begin. We will understand how you can design beam, frame, trusses in STAAD.PRO, how you can do the modeling, how you can validate the results with the manual calculation. Tomorrow we are going to see all those things in detail. So today was the first session, very basics. We just begin it.